I've got a few samples here for you. We want to practice drawing the formulas. So we'll draw structural formulas, we'll draw line angle formulas for these three compounds. Okay? So we have 1-chloro, 3-ethyl cyclopentane. Now when you begin to draw the formula, the structural formula, the line angle formula for an organic compound, I like to start at the end of the name and work backwards. Okay? Because the backbone, the carbon chain, is going to be here at the end of the name. It's going to be the identity of it. Okay, so we have pentane. Pentane is 5 carbons. Ane is an alkane, meaning all the bonds are single bonds. So let's draw 5 carbon chain. Okay, there's the pentane. Now, we notice that it says cyclo. Okay, cyclo means instead of this chain being straight, it's going to be cyclic. It's going to be ringed. So, let's take this chain and let's make it a ring. So we have one, two, three, 4, 5. There we go. Not my best drawing, but it works. Okay, so there's the 5 carbon ring, cyclopentane. Now let's go and have an ethyl. Ethyl is 2 carbons, and it's a substituent here. So a 2 carbon group substituent on the 3rd carbon. Okay, on the 3rd carbon. So right now we don't have any of these especially designated as number 1, 2, 3, 4, 5. So let's just pick a carbon and put an ethyl group. So CH2, CH3. There's your ethyl group. Now that carbon is going to be the number 3. We want to put a chloro on the number 1 carbon. So we can count backwards. So if that's 3, then this could be 2, this could be 1. If you would rather go 2, 1 and make this carbon number 1, that would be perfectly fine. Okay, 2, 1. So you can choose either to be the number 1 carbon. And we put chloro. 1 chloro, that's carbon number 1, 2, 3 with the ethyl. See, and this could not, you couldn't number it 1, 2, 3, 4, because then that would be 1, 4 versus 1, 3. And we want the lower number position. Okay, so 1 chloro, 3 ethyl cyclopentane. If we want to draw that as a line angle, then we draw our cyclopentane, and there we go, kind of straighten it up a little bit. Okay, so there's our cyclopentane, and then our ethyl group. Okay, we show that bend so that we recognize there are 2 carbons, and then the chloro, okay, comes off right here, and we have to designate the Cl so that we know there's a chloro there. Alright. Okay, we have 4-isopropyl 3-methyl heptane. Heptane is 7 carbons, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7. On the 3rd carbon, we want a methyl. 1, 2, 3. Methyl. The 4th, we want an isopropyl. Okay, so something like that. Okay, as a line angle. Okay. 3rd carbon, methyl. 4th carbon, isopropyl. heptane 7. And the ane, remember, means saturation, so all single bonds. Okay, and then we have hexene, and the number 2 is telling us where the double bond is. This is an alkene. So let's have 1, 2, 3, 4, 5, 6 carbons. Number 2 has a double bond. Okay. On number 4, we have a fluoro. So 1, 2, 3, 4. We have a fluoro here. Number 3, we have a chloro. Okay. If you'd like to go ahead and put the hydrogens on, we can just shove them. Okay. So showing this as more of an expanded structural. So you can see all of the pieces. And if we want to do it line angle, it would look like this. Okay, there's that double bond. Okay, 1, 2, 3. Let's go and put our chloro there. 4, we'll put our fluoro there. 5, 6. Okay.